Okay, the problem is I'm given two strings and I need to determine if any rearrangement of string B occurs as a substring of the first string, string A. So as I have some constraints, comparison is not case sensitive and input string sizes vary. So I'm always going to check if string B is going to be an anagram of string A. So that should kind of make it half easy in the sense that if string B is bigger than string A, immediately false. That's no way it can be an anagram of string A. So that's one thing. So I understand that. Yeah, my input is two strings. My output is a boolean. And true if second string is an anagram of the first string. Other problems I've seen similar is like repeated substrings. That could be, that's one of the similar problems. I'll be needing, let's see, I'll be needing some string member functions. Since case does not matter, case doesn't matter, and I'm gonna guess that space doesn't matter. So I'll be needing lower and replace. What else I need? I'll need a for loop. And let's see. I'll also need a counter. Counter to like if all the characters in string B appear in some kind of substring in string A, I'm going to count all the characters. If all the characters, well, if the counter reaches the same amount of the length of string B, well, then the substring exists. So that's what I'm going to do. And let's see, what's my plan? So my plan is, let's see, take the input, convert inputs to all lowercase, and replace all spaces with empty string. Essentially getting rid of all those spaces. Let's see. So I'm going to need a for loop, and I'm going to go in the range of, let's see, for loop, range of, let's see, the length of, we'll go through the length of string A, but I'm checking each part of the string A with the length of string B. So my range is from length of string A minus the length of string B, and that's actually too big of a number because that's just how indexes work. So I need to add 1 here, so I'm not off by 1. So that's my range. Then I'm going to have a count that starts at 0. I need a for loop. I'm going to need another for loop that checks every character in string B. I'm going to constantly check in string B. And then if a character is in a substring of a substring of A. So I'm going to do STRA. Now this is going to be interesting because it's going to be I plus the, well, I all the way to I plus the length of string B. And I don't need a +1. I don't want to include the index of the last one of string B, so this is perfect. So I'm only going to check every small section of the string A. Like for example, the Morse code here. Let's combine this and let's assume everything is lower. So I'll be checking every character in here to check if everything is in a string like this. Like whatever the length of this is, which is 12 characters, I'll check every 12 characters here. So I'll be checking this part. Then the next 12 characters, I'll be checking this part. And I'll be checking if all the characters are in these sections of the original string. And so on and so forth, like this. From the second one to the next 12 characters, I'll check if the Morse code is all the characters in there, and so on and so forth. And that's how my for loop is going to work. So if there is one, then count +1. Then let's see, outside of that for loop, I just need to check if the count is equal to the length of string B. If it is, well, I'll return true. Then in the end, if everything passes through without, if this triggers, if this statement never triggers, well then I return false. And that's the end of my function. Everything gets passed through. In the end, I return false. If the count ever reaches a string length of string B, that means all the characters belong somewhere here. And then that's how I can tell there's an anagram. And that's it.